Welcome back. In this video, we will be looking at alcohols. And as we know, the functional group for alcohol is the hydroxyl group. The general formula is CnH2n plus 1 OH. Remember, N is the amount of carbons. So for example, if the alcohol has 3 carbons, 2n, that will be 2 times 3 plus 1 is 7. So C3H7OH. If we were to name this alcohol, once it has 3 carbons, we know the prefix is prop, and alcohols end in anal. So it's propanol. Right? But with propanol, the OH group, it can be on carbon 1 or it can be on carbon 2. So with alcohols, like with alkenes, we have to tell where the functional group is. So in this one, it is 1 propanol, and in this one, it is 2 propanol. Alright? If you want to say propan 1-al or propan 2-al, that's okay as well. Some more examples. Alright, so here we have some alcohols. So our first alcohol, we have 1, 2, 3, 4 carbons. Alright, so we know that that is. And the OH group is on carbon 1. So this is not carbon 1. Remember, you count from the end closest to the functional group. So that would be butan 1-al. And we have a methyl group, so carbons 1, 2, 3. So we have a methyl group on carbon 3. So that's 3 methyl butan 1-al. For this one, it's a cyclic compound, 6 carbons, 1, 2, 3, 1, 2, 3, 4, 5, 6. And where the OH group is, that's carbon number 1. So all we need to say is cyclo for cyclo because it's cyclic, and it's hex for 6 carbon. So it's hexanol. So it is cyclohexanol. This one is this skeletal structure. So 1, 2, 3, 4, 5, 6 carbons. So that is hexanol. It's on carbon 2. Hexan 2-al. Right? And we only have a methyl group on carbons 1, 2, 3, 4. So that's 4 methyl X2 anal. Alright, so you can pause the video here and name these two. Alright, and then play it and see if you get them correct. Alright, so you can pause it. So this one, we have 1, 2, 3, 4, 5 carbons. This is closer to this end, so we count from here. So it's 5 carbon, hydroxyl group on carbon number 2. So that is 2 pentanol. Alright? And then now, since we're counting from this end, we have a methyl group on carbon 3 and a bromo group on carbon 4. So that would make it 2 bromo, 3-methyl 2-pentanol. So it's 2-bromo 3-methyl 2-pentanol. Then this one is 4 carbons again. That's butanol. The OH is on carbon 2. So we know that that would be 2-butanol. And we also have a chloro group on carbon 2. So that's 2-chloro 2-butanol. Alright? So again, when they say it like this, like butan 1-ol, hexane 2-ol, or you just say 2-pentanol or 2-butanol, it doesn't matter. Alright? So that's naming alcohols. Now we already did isomerism, so we know that alcohols can give you the position isomer. So these, the propan 1-ol and propan 2-ol would be a position isomer. If you remove a carbon, that is when you would have the chain isomer. We already did isomers already, so we're not going to do it again for alcohols. So after this, we're going to look at the reactions of alcohols. Okay, so before we look at the reactions of alcohols, we need to know the types of alcohols, because when you do oxidation of alcohols, depending on the alcohol, you will get a different product, or you may not get a reaction at all. So there are 3 types of alcohols. We call them primary, secondary, and tertiary. So these are the 3 classes of alcohols. Now, what you are going to do, alright, when you get done alcohol, you are going to pay attention to the carbon that is bonded to the OH group. Right? You can interpret it as in terms of how many hydrogens are attached, or in terms of how many carbons are attached. So we will do it in terms of hydrogen first, and then in terms of carbon. So the carbon with the OH group, if 2 hydrogens are attached to it, then it's a primary alcohol. So the carbon with the OH, if you have 2 hydrogens on it, it's a primary alcohol. If you have only 1 hydrogen attached to it, then it's a secondary alcohol. If no hydrogens are attached, then it's a tertiary alcohol. Right? And next way to interpret it now is to look at how many carbon atoms are directly attached to it. In this one, we see that only this carbon atom, even though you have 2 more carbon atoms, only this one is attached to it. So if 1 carbon is attached to it, so the carbon with the OH group, if 1 other carbon atom is attached to it, it's a primary alcohol. If 2 carbon atoms are directly attached to it, it's a secondary alcohol. And if it's 3 carbons directly attached to it, it's tertiary. So you can do it in terms of how many carbons are attached or how many hydrogens, right? But it's the hydrogens that are attached that is taking part in the oxidation reaction. So this one, without any hydrogen, it will not be oxidized. So tertiary alcohols are not oxidized. Only the primary and the secondary alcohols. Alright? So just look for the carbon that is bonded to the OH. 2 hydrogens are attached, it's primary, 1 hydrogen, secondary, no hydrogen, it will not be oxidized. which is a tertiary alcohol. Alright? So now we are going to look at how we can prepare alcohols. So which other functional groups present that we can react to get an alcohol? So we know that if we hydrate an alkene, so the first one, so before we do reactions of alcohols, we are going to look at how we can prepare alcohols. So we know that if we have an alkene and we hydrate the alkene, we can get an alcohol. So reacting the alkene with water, right, and concentrated sulfuric acid, we are going to get the corresponding alcohol. Alright, so if this is ethene, we are going to get ethanol. So one way to prepare alcohols is the hydration of alkenes. Right? So the reaction is called hydration. Second reaction, if you have an alkyl halide, alkane, same thing. Right. If you have an alkane and you react it with sodium hydroxide or just water, which is the hydrolysis of the alkane, you will also get the alcohol. So if this is bromoethane, we know that the OH group will replace the bromine because this reaction is nucleophilic substitution. So again, you can get an alcohol from a haloalkane, and it is nucleophilic substitution, whether SN1 or SN2. So hydration, nucleophilic substitution, those are two ways of getting an alcohol. If you have an ester, and you hydrolyze the ester, you will get back the corresponding alcohol. So you will get the acid and the alcohol. Remember, if it's an ester, we have the carbon double bond oxygen. That part over here, that's the acid. This part is oxygen single bond carbon. This portion is the alcohol. Alright. So this is methyl ethanoate. So the ester would have been methyl ethanoate. That means the alcohol should be methanol. And the carboxylic acid is ethanoic acid. So you can hydrate an alkene, you can do nucleophilic substitution with the alkane, and you can hydrolyze an ester. Whether acid or base, you will get back the alcohol. In this instance, it's acid hydrolysis. Alright? So these are three ways in which you can prepare an ester. We can also reduce aldehydes, ketones, and carboxylic acids to get back alcohols. Alright, so still on the preparation of alcohols. If you have an aldehyde, so the functional group, as you should know for the aldehyde, is CHO. Alright, so C double bond O H. So the difference between the aldehyde and the carboxylic acid is this oxygen here. Alright, so the aldehyde C double bond O H, the carboxylic acid C double bond O OH, and the ketone, the carbon with the double bond oxygen, it has to be surrounded by two other carbons. So you can take all of this to be the ketone group. Alright, so the reagent for the reduction of aldehyde, carboxylic acids, and ketone is lithium aluminum tetrahydride. So if you have a carboxylic acid, it will be reduced to a primary alcohol. So if you have ethanoic acid, well, this is not a carboxylic acid, aldehyde. So if you have the aldehyde, it will go to the corresponding alcohol. So this is ethanol. So when we look at aldehydes, you will know how to name them. So this is the aldehyde, you will get the corresponding alcohol. If it's a carboxylic acid, you will get the corresponding alcohol again. So this is ethanoic acid, you will get ethanol. This is propanone, which is a ketone, so you will get propanol. However, notice that the ketone, the double bond, look at the structure, the ketone will give you a secondary alcohol, because for carboxylic acid and aldehyde, this group, the functional group, is at the end, you will get a primary alcohol. But the ketone will give a secondary alcohol. So if you want alcohol, you can dehydrate an alkene, hydrolyze an ester, do nucleophilic substitution with either alkanes using sodium hydroxide or water, and finally you can reduce an aldehyde, reduce a carboxylic acid, or reduce a ketone. So those are the ways that you can prepare an alcohol at this level. So now we are going to look at some actual reactions of alcohols. So this was the preparation of alcohols. Now we are going to do reactions of alcohols. Okay, so the first three reactions of alcohols that we are going to look at is combustion, dehydration, and reaction with sodium metal. So when we're in combustion, we react the hydrocarbon or alcohols the presence of oxygen, and we get carbon dioxide and water. So once this supply of oxygen is sufficient, you will get carbon dioxide. If it's not enough, you would have gotten carbon monoxide. Right? So when you react the alcohol with oxygen, you should get carbon dioxide and water. So all you need to do now is to balance the equation. So we have 2 carbons here, so we need 2 there. 5 and 1, 6 hydrogen, so I need a 3 here. In terms of oxygen, we have an oxygen here and oxygen in the alcohol. So over here, 2 2s, that's 4 oxygen, 3 1s, 3. So that's a total of 7 oxygen. Alright? Remember, 1 oxygen is present here. So to make it easy, if you have a total of 7, to account for this 1 oxygen, just subtract 1 and you will end up with 6. So now we just need 6 atoms of oxygen. So I put 3 here. So 3 2 6, 6 and 1 is 7. 2 2 is 4, 3 1 is 3, 4 and 3 is 7. So to account for this oxygen, when I get the total amount of oxygen over here, I just subtract 1 from it, so I get 6. And so 2 3s, that is 6. Same thing for this one again. 3 carbons, 3 carbons. 7 and 1, 8. 2 4s, 8. 3 2s, 6. That's 6 oxygen. 4 1s, 4. 6 and 4, that is 10. To account for this 1 oxygen, I'm going to subtract 1. That leaves me with 9. When you are balancing the combustion equation, if you have an odd number, you are going to use a fraction. So 4.5 times 2, that is 9. So 4.5 O2. So 2 times 4.5, that is 9. Or you could use an improper fraction, so 2 4 is 8, 8 and 1 is 9. So that would be 9 over 2 O2. So if you get an odd number for oxygen, just put it over 2 and you have the answer. 9 over 2, that's 4.5. 4.5 times 2, that's 9. Alright? So that's for combustion. With dehydration, hydration converts the alkene to the alcohol. Dehydration, you are converting the alcohol to the alkene. So the reverse reaction would be the alkene plus the water to give you the alcohol. So if you dehydrate the alcohol, you should get back the alkene and water. Right? And these are the conditions: temperature and concentrated sulfuric acid. And for reaction with sodium metal, like metals with acid, the sodium metal is going to replace the hydrogen of the OH group. So you get the ethoxide ion. So this compound here, that is sodium ethoxide. Right? So when the hydrogen is removed, right, because it's 2 carbons, we say it's ethoxide. So it's sodium ethoxide. So the sodium will be bonded with the oxygen. So it's sodium ethoxide and you get hydrogen gas being present. Alright? So those are the first 3: combustion, dehydration, and with sodium metal. We are going to look at the other 3. Alright, so for the next reaction, it's oxidation. And the 2 oxidizing reagent that you will use at this level is potassium permanganate or potassium dichromate. If you use potassium permanganate, it will change from purple to colorless because the oxidation state is changing from +7, which is why potassium permanganate is purple, and when it goes to the 2+, it is colorless. If you use dichromate in potassium dichromate, chromium is in the 6+ oxidation state. When it is reduced, it is 3+. That is why it changes from orange to green. So in oxidation, you use potassium permanganate or potassium dichromate. These are the color changes. The acid used, once you say /H+, it means it is acidified. And we use sulfuric acid. So we acidify it with sulfuric acid. So we add a small amount of sulfuric acid. Now, in terms of the alcohol, if you have a primary alcohol, whichever of these you use as the oxidizing agent, so this is just the symbol for oxidizing agent. So whichever of these you use, it will convert the primary alcohol to the aldehyde, but because they are a strong oxidizing agent, it will convert it. It will oxidize the aldehyde further to carboxylic acid. So primary alcohols are oxidized to aldehyde and finally to a carboxylic acid. So it's primary alcohol to carboxylic acid. For the secondary alcohol, you will get a ketone. Alright? So these two oxidizing agents convert primary alcohol to carboxylic acid and secondary alcohol to ketones. You must remember the color changes as well. Alright? So that's it for oxidation. Alright, so the next reaction, it is called the Iodoform test. Right? And so in this test, you will react the alcohol with the reagents iodine and sodium hydroxide. If you get a yellow precipitate, that means an alcohol is present. But not just any alcohol. It has to be a secondary alcohol because it's a specific group that we are looking for. The carbon with the OH group, it must have a methyl group attached, right? It must also have a hydrogen attached, right? That means a tertiary alcohol will not do it because the tertiary alcohol, no hydrogen is present on the carbon with the OH group. So the iodoform test is for secondary alcohols. The only primary alcohol that will do the iodoform test is ethanol. So ethanol is the only primary alcohol that will do the iodoform test. No tertiary alcohol. So the iodoform test is strictly for secondary alcohols. And it must have a methyl group, a CH3 group next to the carbon with the OH. Because what will happen when you have the secondary alcohol and you react it with iodine in sodium hydroxide, the alcohol portion is going to be oxidized to the ketone, and the iodine will replace the 3 hydrogen atoms of the methyl group. So you get Ci3, right? So the alcohol is oxidized to the ketone, and the 3 iodine ions replaces the 3 hydrogens. Now you are not required to know any mechanism for this reaction, right? You must know that when you react a secondary alcohol with iodine and sodium hydroxide, you will get a yellow precipitate of triiodomethane. Alright? So after this is formed, this bond is going to break. Right? And you get a hydrogen is added, and you get triiodomethane. 3 iodine atoms, so that's triiodomethane. So what you are interested in is knowing that when you react a secondary alcohol with iodine and sodium hydroxide, you will get a yellow precipitate of triiodomethane. So you must remember your reagent, right? The type of alcohol and what should you look for. So the reagent is iodine in sodium hydroxide, right? You are looking for a methyl alcohol. That's an alcohol with a methyl group attached. And you will get a yellow precipitate, which is triiodomethane, right? So that's it for alcohols. The next reaction would have been esterification, but I will do esterification when I'm doing carboxylic acids, right? So alcohols is esterification is a reaction between alcohols and carboxylic acids. So when I do the video on carboxylic acids, I will do esterification. So that would have been the final reaction. So that's it for alcohols, right? So the study, and remember the different tests, how you can prepare it first, and then the type of reactions that it will do. Remember, primary alcohols give aldehydes, then it will go to carboxylic acids. Secondary alcohols give ketone. If you reduce the ketone, you get secondary alcohol. Reduce the aldehyde, you get primary alcohol. So that's it. Remember to subscribe and share.